Hey guys, we are going to try to do some multi-step inequalities today. This is section 2.4. The main things you need to remember with this section is obviously the inequality symbols. Make sure you're using those and not just the equal sign. And then you also have to remember about if you multiply or divide by a negative number, you need to flip the symbol at that time. So let's just start with this practice A. I'm just going to go through some of these problems with you so you'll know how to solve these types of problems and get the idea. So the first three problems, you're solving the inequality and then matching the graph that goes with that. So we're going to try number one right here. So I'm just going to write it out. It's 6 minus 5 is greater than or equal to 7. You solve by getting y by itself. So I added 5 to both sides. You get 6y is greater than or equal to 12. Divide by 6, and you get y is greater than or equal to 2. So this means that the solution set for this inequality is anything greater than or equal to 2, any number greater than or equal to 2. So now you're going over here to the side and figuring out which number line matches that answer, which obviously it is C, which highlights everything greater than or equal to 2. Of course, you know about the filled in circle, so the answer for this one would be C. Okay, so I'm going to try the next one here. So number 2 looks like this. 3m plus 5 is less than or equal to 8. Subtract 5 from both sides. 3m is less than or equal to 3. Divide by 3, and you get m is less than or equal to 1. Go over to the side, pick the graph that matches, which is letter A. It's highlighting that every number less than 1 is highlighted, including 1. So this answer would be A. So I think you pretty much get the idea for those. We're going to move down then to a different section here. We're going to go through 4 through 9. We're just going to pick a couple. So I'm just going to pick number 4 right there. You get 3x minus 4 is less than 2. Add 4 to both sides. 3x is less than 6. Divide by 3, and you get x is less than 2. Now, in this section, it does say to graph the solution. So you need to draw a number line. It doesn't have to be very big. You need at least 3 numbers on the number line. So you mark the one that you absolutely need. You need the number 2. And then just pick a number in front of it and behind it, and that's good enough for me. Now this says x is less than 2, so you need an open circle. It doesn't include the 2, and everything smaller than 2 is highlighted. Okay, let's try another one. I'm going to pick number 8. Number 8 starts like this. It has k divided by 3, or k over 3, plus 6 is less than 7. We should get rid of the 6 first. So you might subtract 6 on both sides. You're left with k divided by 3 is less than 1. Now to get rid of this denominator, you multiply by it. It cross simplifies. You got to multiply to this side, and you get k is less than 3. To graph it, you need the number 3, and then 1 ahead of it, 1 before it, and graph it. Now this doesn't have an equal sign, so again you have an open circle, and you're highlighting everything less than 3. Now I'm going to pick one in the next section. The next section has multi-step. It might have multiplication, it might have division, it's got all that. So let's try number 10. We have 5 minus 4n is less than 8 minus 5n. There's no distributive property. There are no like terms on the same side. So we're just down to getting the variable on the same side. So I'm going to add 5n on both sides because I know then when I add the 5n, I'm going to get a positive answer here. So I'm going to do 5 plus 1n is less than 8. Subtract 5, n will be less than 3. Graph it. 3, 4, 2, no equal sign, open circle, you're showing less than. What do you think? Hopefully it doesn't look too bad. Now, you are going to run into some interesting situations, so let me try to see if I can find one. I'm going to do number 16. Number 16 looks like this. 8 times x minus 3 is greater than 4 times 2x minus 6. Now, when I do the distributive property, I'm going to get 8x minus 24 on this side. I have the greater than symbol, and I'm going to get 8x minus 24 on this side. Now, some of you are going to notice that these have the same thing on both sides. And we've done some of this in the earlier sections, and normally you would think that this would be IMS. But we have to remember we're doing an inequality now. So we need to finish this out and see what, I want you to see what happens. So if I get rid of this 8x to get my x's on the same side, you know that they cancel out. You get negative 24 is greater than negative 24. Is that true? Negative 24 is not greater than negative 24. It's actually equal to it, but there's no equal sign here. So this actually has no solution because you actually get an untrue statement. So when it comes to inequalities, you can't just look for if they're the same. You have to read the inequality and see if it's true. This one is not true, so there is not a solution for this. Let me erase that. Now I'm going to peel this over here. And let's try number 14, so you can see that one. 9w minus 4w plus 6 is greater than or equal to 1 plus 5w. Now, some of you might see what's going to happen here. I'm going to get 5w on this side. I'm adding 6. And then I get 1 plus 5w on this side. Now, if you can take a look at this, you see that the variable has the same coefficient, so you know they're going to wipe out. They're going to disappear. What you're looking for is what kind of sentence do you have at the end. So these are going to cancel out. You're going to have 6 is greater than or equal to 1. Is that true? Yes. So this is actually considered all real numbers. This symbol tells you all real numbers. You draw an R and another line through it, and it represents all real numbers. Now, there is a slight difference between saying all real numbers and infinitely many solutions, but that will come up later in your upper level classes. So right now, you just need to understand that all real numbers and infinitely many solutions are very similar, and they pretty much mean the same thing, and that's all that we need to know at this point. So in inequalities, we're going to write all real numbers. If you accidentally write IMS, that's okay too. You'll learn much later that there's a very, very slight difference in it, okay? All right. Oh, I'm sorry. I forgot to tell you how to graph that. It doesn't say in here to graph these problems, but I want to show you what that looks like. If you get an answer of no solution, a graph that's showing no solution just doesn't highlight anything. So I could do a quick graph like that. I have nothing highlighted, so there's no solution on that graph. Now, if I want to show all real numbers where any number will work, you have to highlight the whole thing. So I can do a few numbers like this. I'm going to include 0, and I'm going to go both directions. That's showing that any number along that number line will work. Just to give you an example. Okay. Sometimes if it's no solution, they don't expect you to graph it. But every once in a while you get a computer test that's going to show you what a no solution looks like. Okay. Well, I think that pretty much sums it up. So hopefully when you get to doing some problems in your textbook on section 2.4, you'll have a better idea of what to expect.